Hello. Hi again, folks. In this video, we're going to talk about inequalities, what they are, which we've talked about them a little already. And we're going to graph them. And we're going to talk about what's called interval notation. There are 4 inequality symbols, and 2 of them we have already talked about. When we have a sideways V pointing to the left, that symbol says is less than, and A is less than B means that A is to the left of B on the number line. And when the symbol, the point of the symbol is to the right, that's the is greater than symbol. And if A is greater than B, that means that A is to the right of B on the number line. And then you probably, maybe in your previous courses, have also seen the symbol for less than or equal to, and the symbol for greater than or equal to. If A is less than or equal to B, we have the less than sign with 1 bar underneath it. That means that either the number on the left is less than the number to the right of that symbol, or that those 2 numbers are actually equal. So they might look different, but they're actually the same. And then if A is greater than or equal to B, in order for that to be true, that means that either A is greater than B, or possibly A and B are equal to each other. So -8 is less than 3 because -8 is to the left of 3. And likewise, 3 is greater than -8 because 3 is to the right of -8. Since it's true that -8 is less than 3, we can also say that -8 is less than or equal to 3. Precisely because we've already decided that -8 is less than 3 because -8 is to the left of 3. But I can also say that 3 is less than or equal to 3 because 3 is equal to 3. One number is less than or equal to a second number if either of these 2 things is true. Either the first number is less than the second number, or the first number is equal to the second number. And since we know that 3 is greater than -8, we could also say that 3 is greater than or equal to -8. precisely because 3 is greater than -8. And we could also say that -8 is greater than or equal to -8 because -8 is -8. On these next few problems, we are going to do two things, which with each of the inequalities that we are given. The first thing that we are going to do is we are going to graph all of the numbers that make the inequality true. And then we are also going to write each of the inequalities in what is called interval notation. And you probably have not used interval notation before. But first, we're going to go through all of these examples and we're going to graph them. And then we're going to come back later and we're going to write them in interval notation. So for right now, we're just going to do the graphing. If we want to graph all of the numbers x that are greater than -4, -4 would be at this tick mark on the number line. And if I want my number to be greater than -4, that means my number has to be to the right of -4. So for example, 7 is greater than -4 because 7 is to the right of -4. Three is also greater than -4 because it's to the right of -4. So is, for example, 2. 2 is to the right of -4. Likewise, we could have, say, 1.5 or 1.5. That's to the right of -4. If we want to draw a picture of all of the numbers that are to the right of -4, we would need to draw a dot on every single one of these numbers. And we would keep going forever. And so by drawing this sort of half of a line, I have drawn over that dot that I had put at 2, and likewise the one that I had put at 1.5 and 3 and 7. They have all been covered up by me shading in this entire part of the number line. And so I'm going to erase those example numbers for right now. And notice x could be 3.9, or X could be negative 3.992. And that number, negative 3.992, would still be to the right of negative 4. The first example and the second example are almost the same. We're not quite done with the first example yet. But the second example, we're looking for all of the X values that are greater than negative 4 or are equal to negative 4. And if I'm thinking of a number that is greater than negative 4, that means that my number has to be to the right of negative 4. So again, any of these numbers on this part of the number line going on forever to the right, all of those numbers are to the right of negative 4. So we need to do something in our two different pictures to show that in problem 2, X can be negative 4 because negative 4 is equal to negative 4. But in problem 1, X can't be negative 4, but it could be something like negative 3.99996. To show that negative 4 is included, in the past, you may have seen that people will draw a solid dot where negative 4 is on the number line to show that that endpoint of this ray that's going to the right is included. And then to show that it's not included, an open circle is used. And that is one method to show the difference between whether negative 4 makes these inequalities true or not. So negative 4 itself is not greater than negative 4. So to show that we don't want to include negative 4, we have an open circle. And to show that in problem 2, it is okay if X is negative 4, because negative 4 is equal to negative 4, we use a solid dot. There is a second way of showing that distinction. I'm going to come back to that in a moment. In problems 3 and 4, we want all of the numbers that are less than negative 4 in problem 3. So we want all of the numbers that are to the left of negative 4 in problem 3. And in problem 4, we want all of the numbers that are less than negative 4 or equal to negative 4. So we want all of the numbers that are to the left of negative 4 or possibly equal to negative 4. So in both problems, we're going to be highlighting all of the number line to the left of -4. But in the second problem, in problem 4, we're going to include the -4, the endpoint of that ray. But in problem 3, we're not going to include. Like I said, we're going to come back to a second way of showing whether or not the endpoints are included in a minute. When we have a double inequality, where both of the inequality signs are pointing the same way, this is a compound sentence. It literally says that -4 is less than x and x is less than 7. So -4 is less than x and x is less than 7. And if I were actually writing this to be read in English, I would maybe start by saying the number -4 otherwise I have to spell out negative. So the number -4 is less than x and x is less than 7. That's what it literally says. A better way of reading this is to say the number x, some unknown number x, is between -4 and 7. And if we look at problem 5 compared to problem 6, the only distinction is that the second inequality, instead of being a strict less than symbol, it's a less than or equal to 7. So we would read it, if we wanted to read it literally, we would say the number -4 is less than x and x is less than or equal to 7. Or we could say that the number x is between -4 and 7, but including 7. Okay, so here's the number -4 on the number line. Here's the number 7. And in both problems, x can be any number between -4 and 7. But in the problem 5, x cannot be -4, but it could be -3.999992. And x can't be 7, but it could be 6.994. So we're going to have an open circle at both ends of our picture. In problem 6, x can be any number between -4 and 7, but -4 has to be strictly less than x, so we don't include the endpoint at -4, but it is okay for x to be 7 this time, because x could be less than or equal to 7. So x is between -4 and 7, including 7. It's possible in another problem that again, we want x to be between -4 and 7, but this time we want to include the -4 because of the or equal to, but we don't want to include the 7 because there isn't an or equal to on this second less than symbol. So we would say x is between -4 and 7, including -4. And if we wanted to be even more clear, we could say, but not including 7. And in problem 8, x is between -4 and 7, but we're including both the -4 and the 7. So we'll have a solid dot to indicate that both endpoints are included. So now we're going to go back to the first page, but I'm going to show you the alternate method. So at first, we graphed the inequality, and we haven't yet talked about interval notation. But we used a solid dot to include the endpoint, and we used an open circle to exclude or to not include the endpoint. So I'm going to call that method number 1. And now we're going to look at method number 2, but we still haven't talked about interval notation. Method number 2 uses a square bracket to include the endpoint, and it uses a round parenthesis to exclude the endpoint. So before, we used an open circle to exclude and a closed circle to include. So what this new method does is it uses, in this case, a parentheses to show that -4 is not included. And in problem 2, it uses a bracket to show that -4 is included. And when you use this method, you have to be a little bit careful, because if you draw either one of them fast, it can be hard to tell the difference about whether you drew a bracket or a parentheses. When we are shading all of the numbers to the left of the endpoint, then our symbol, our parentheses or our bracket, is an ending parentheses or a bracket, not a beginning parentheses or a bracket. So in problem 3, we would use a round parentheses to show that -4 is not included, but we use a right-hand parentheses, whereas in problem 1, we used a left-hand parentheses. Likewise, in problem 4, we're going to use a right-hand bracket. And also, sometimes if you're not careful, your arrowhead starts looking like a parentheses. So now let's take a look at the problems that were on the second page. In problem 5, x is between -4 and 7, but we're not including -4, we're not including 7. So previously we had open circles at both ends. So this time we're going to have parentheses at both ends. And we'll have a left-hand parentheses at the left endpoint, and we'll have a right-hand parentheses at the right endpoint. Okay. So now we know that if X is between -4 and 7, not including -4, we're going to use a parentheses, but including 7, we're going to use a bracket. And we'll use a left-hand parentheses at the left endpoint and a right-hand bracket at the right endpoint. If the -4 is included, but the 7 is excluded, then at -4, we're going to have a bracket, and at 7, we're going to have a parentheses. And if both endpoints are included, then we're going to have a bracket at both endpoints. So we'll have a left end, we'll have a left bracket, a beginning bracket at -4 and a closing bracket at 7. Now we're ready to write each inequality in interval notation. But we're actually going to start with the last problem. And work our way back to the first problem. So here's the second page. Using method 2 with the parentheses and the brackets. And what interval notation does is it sort of imitates the picture but by using the keys on a standard keyboard. So our variable name in problem 5, well, in all of our problems, the variable's name is X. So we are going to write X. And then we're going to write this funny looking E. And that E is a lowercase printed Greek E. And in the Greek language, they don't say E, they say epsilon. And that epsilon, when you read it, it says is an element of. Or you could say belongs to. So we are saying the number X is an element of the following set of numbers. And what we type looks essentially like our picture using method 2 with the parentheses and the brackets instead of the open circles and the closed circles. So our picture starts at -4 with a beginning parentheses. And then we're going to put a comma. And then our picture ends at 7 with an ending parentheses. So this says the number X belongs to, the number X is an element of, the number X is a member of, the interval, the chunk of the number line, the piece of the number line, between -4 and 7, but not including either endpoint. So in problem 6, when we graphed it with method 2, we had a parentheses at -4, but we had a bracket at 7. So X belongs to the piece of the number line that starts at -4 and ends at 7, but does not include -4 and does include +7. In problem 7, X is between -4 and 7, including -4, but not including 7. And in problem 8, X belongs to the piece of the number line, the interval of the number line, between -4 and 7, including both endpoints. Okay, so now we're going to go back to the first page where when we used method 2, the parentheses and the brackets, as opposed to the open circles and the closed circles. And now we're going to use the interval notation to describe each of these pictures on the first page. Again, our variable's name is X. So X belongs to, X is a member of, X is an element of, the piece of the number line, the interval of the number line that starts at -4, but not including -4. And now we have a problem because there isn't a right-hand endpoint. Our graph continues forever. So we write our comma like before. And how do we say that it goes on forever? Well, we use the symbol that means infinity, which isn't a number, but it's an idea. And the symbol for infinity is a sideways 8. And it's impossible to ever get to infinity, because no matter how far to the right you go on the number line, there's always farther to go. So we always use a parentheses not at, but on the, if the graph is unbounded and going forever to the right. So in problem 2, we're going to use the same kind of idea. X belongs to the piece of the number line that starts at -4 and continues forever to the right. And to convey that idea, we'll use the infinity symbol with a parentheses. Now problem 3. Well, the variable's name is X. X belongs to is an element of a piece of the number line. This time, the graph is unbounded to the left. And on the right, it's bounded by -4. But we're not including -4. So there's going to be a parentheses there. How do we show that the graph is unbounded to the left? Well, we're going to use the symbol -infinity. And since -infinity isn't a number, and since we can never get to -infinity, we will use a parentheses. And for problem 4, a similar idea, we read our picture from left to right, just like we read in English from left to right. So the part of the number line that we are including is unbounded on the left and ends at -4 on the right, including -4. And so we use a bracket. We're going to do some more with inequalities in the next video.